Welcome back to our last video. Yes, we are nearly on the end. So we covered basic energy efficiency in correlation with EDGE, which is a green building standard for design of buildings and to assess buildings. Now let's focus on labeling of energy efficiency buildings. So there are several energy label for buildings at the market. Uh, in a lot of economies, the energy efficiency labeling is compulsory. It is like a energy efficiency performance indicator for potential property owners, buyers, or tenant. Furthermore, also governments are interested in the energy efficiency performance of buildings. Here you can see, for example, a few designs or a few systems of energy efficiency labeling. So we have, for example, here the UK with a typical A to G, like the most of them have that now, labeling, the rating system. So it's called energy efficiency rating. Then we have the German Energy Ausweis. Then we have the American Home Performance Label. I think this is from state to state, it's different. And then we have the one from Ireland, which is also focusing on CO2 emissions. Okay, so the energy passport is a qualitative label allowing you to easily compare energetic performance of different buildings without necessarily being an expert. So it's actually one of our aims of that course is that you can read that energy label or assessment of an energy efficient tested building. The main result that should be understood is that energy output of the energy output index. It calculates the required energy to maintain the building and uses a predefined calculation tool or method, similar to the A to E rating. So that is this kind of rating there. There are currently two versions on the market. One which indicates the energy consumption via metering. So that is when you already have a building and you assess it and you have the meters to read and so on. And there's the other one version is the calculation of the energetic demand. This is where you have to do a little bit more work. You have to calculate the U value and windows and walls and orientation and so on. And it's for new building or renovated building. So for now, I'm not okay. So in Mongolia, we do not have actually an energy pass yet. However, there are several cooperation partners working in that field. So, for example, MUST, the Mongolian University of Science and Technology, then the project which I'm working in, the the EEP, Energy Efficiency Project, EDGE, the software which we are working with. TOC is a Mongolian Sustainable Finance Association. Then we have the IFC, the International, what was it? I will tell it later. And as well, I wrote it somewhere, I forgot now. Then we also have Arik Bank and Hak Bank with the Sustainable and Eco Banking Program. And on the government side, we have the Municipality of Ulaanbaatar and the Energy Regulatory Commission. with the LEAP Local Energy Efficiency Action Plan, as well as UNDP with the NAMA project. So in both in the LEAP and in the NAMA project, the GIZ is also involved in that field. I think that's what we also had in one of our first presentation, I think the second one. So how do they actually look like? So how does a proposed version of an energy pass for residential building look like? I hope it can be seen here. So this is the draft unofficial version of Mongolia on the left, and here on the right, it's for me the translation. So I think I can go out of the picture now, not more needed here. So I will do that one and go down there. So named it is Energy Pass for residential buildings. Let's go step by step through it. Let's start from the top and go down to the bottom. So here, for example, you have the building data such as size and net floor area, location, and then you have here the rating area, so energy demand or consumption, depending on a new building or existing building. Then you have the rating from A++ to G here, for example. The rating A, for example, again, for example, would be the passive house standard. In this case of that building, it is an A rating from 85 kilowatt hours per square meter per year. So this is a figure here. The standard would be 328 kilowatt hours per square meter, and that would be a D rating. And on the right side here, you see the CO2 emissions for the building, for here, for example, for heating and electricity, etc. And below we have the heating demand or consumption, depending, per square meter, and in the year as well. So this is, I think it's not very visible. So that is the per year. Also some data here. Let me see. Yeah, it's kilowatt hour per year, and then the last two figures here are the heat capacity per year and per square meter, I think. Yeah. So where the let me see. Yeah, well, as heating capacity for the building. So where does, not this one, but where does these figures are coming from? That, because it's just the pass, but on the pass you have actually the calculation papers in the back. So here, for example, we have, let's say it in that way, only certified professionals, energy auditor and energy consultant can collect the data. The data is based actually on our topics which we had in our presentation 2, 3, 4, with the main focus on topic 4, diverse heat losses, orientation, which is here under number 13, I think. Here, these are the heat losses. Orientation of the building, then the wall calculation, window, etc. So all the calculations are there. And here on the bottom, here you can actually find then the 85.4, which we have seen on the side before, kilowatt hours per square meter per year. For the CO2 calculation, the energy demand is the base, that one. base figure. And of course, here we are back to the primary energy. So where is the energy coming from? Is it coal, or is it gas, or is it renewable energy? That makes a big difference in the CO2 emissions. And of course, it's for heating, electricity, etc. Okay, so let's go on my favorite page. So congratulations, you have made it through. We are through the basic training for energy efficiency in the building online course from GIZ EEP project. So congratulations. And the way forward, well, that depends a bit um, on what the COVID-19 is doing. So the circumstances in the autumn and beginning of winter. So the idea is actually that we start our practical assessment of buildings as a cross-sectoral group work with the use of Edge software. So this is actually the idea to assess a building. The plan is to have a group of 4 to 6 people from different trades and departments to assess together different buildings on site. That's the idea behind. So let's see how we will do that. That is really depending on the COVID-19. And anyway, thank you very much for being with us during the e-learning course. Thank you, the GIZ EEP CCHC, which is a Capital City Housing Corporation team. Thank you very much.